My name is Cadet Brian Mathwick and my partner is Cadet Ethan Cook. This is our Arctic Climate Change Deliverable 2 Bravo. Weather stations have been recording temperatures from 1873 to present. They have demonstrated an overall increase in temperature rate, which has caused significant effects on the environment around it. This may lead to new opportunities for oil companies when ice is receding and openings for drillings occur. To investigate this, me and my partner have found all weather stations north of latitude 63.5, which we defined as the Arctic. From there, we conducted an analysis on the overall average temperature change at each weather station to decide if this is valuable information. To the left, we have a scatter plot of all of the data from all of the weather stations. As we can see, data is much more abundant towards the early 2000s than it was in the late 1800s or early 1900s. So data around this area is going to be much more accurate. We then found the least squares slope for each weather station. This allows us to decide if the temperature change at this weather station is overall positive or overall negative. To the right is a graph of each weather station and its least squares slope. Note that 365 of the stations exhibited positive least squares slope and 224 a negative least squares slope. What this means is that 365 weather stations have shown an increase in temperature and 224 stations have shown a decrease in overall average temperature. We then picked the most prominent weather stations when it comes to temperature changes. We picked the stations based on which ones had the most effect on the temperature change, but we also considered the amount of data each weather station had. For example, the weather station with the most significant least squares slope had very few data points. A key note that the first two are both in Alaska and the second two are in Russia. The third one in Canada is a negative least squares slope. After doing some research, according to the EPA, over the past 60 years, average Alaskan temperatures have risen 3 degrees. This is twice as much as the rest of the U.S. Warming in the winter is 6 degrees higher. This has disrupted ecosystems and has caused earlier breakup of ice. Additionally, the state will become drier due to increased evaporation.